Hey guys, welcome to episode 30 of the Trading Signal Coding Sessions series. At this episode, I'm not going to actually code, but I'm going to just explain how all this works because I reach a point where we have something that is usable. This is like the second iteration of the Trading Signals project. The second iteration comes after the second iteration of the peer-to-peer network, which this project depends on. Okay, so I'm not going to go into the coding details here, only an explanation for users, or in this case, for people that would like to test this in the same way with the same setup that I have here. So let's jump into that. So the first thing you need to do is to come to workspaces, plug in workspaces, and oops, well, plug in workspaces, trading signals, and load this trading signal demo that is the same that I have here. Okay, here you will find the Lightning Strike trading system. Two copies of the trading strike like the system, one for sending signals out of it, and the other one for receiving signals. Okay, and you will see that I have here two tasks. One running a trading bot that is going to emit the signals, and the second is a bot that is going to receive the signal. Also, you will see that here is my user profile, okay, and with the latest technologies added to it, right? So I'm going to explain everything. Um, let's do a quick overview of this. These are all the pieces of the puzzle. You need a trading system to send a signal, a trading system to receive the signal. In practice, when this is going to be deployed somewhere, there will be a user that is going to be the one providing signals and another user that is going to be receiving the signal. But testing that with two different users is like uh, overcomplicating this explanation. So I'm playing the role of both users at the same time. But so if you want to test this in the same way that me, you can do it with your own user, but knowing that in practice, each user is going to be doing only half of these two or one of these two roles. Okay, so let's take a quick look at the trading system that is emitting the signals. Okay, it's exactly the same as the other lightning strike, but we have added this here, outgoing signal reference. Okay, that this reference is some node inside my profile. We'll check that later. So this is what activates this functionality somehow. You can think on these terms. So you need this to activate the outgoing signals feature. Okay. Technically, a lot of things happen out of that, but that's not really what we want to explain here. So then you have the same thing, trigger on, trigger off. You have events in general. Okay. Where even with their situations and conditions, you can have announcements or whatever you like. But this is the new functionality, outgoing signals. If you add this node, then you can add an outgoing signal reference. That means that you're going to be sending signals to whatever this is pointing at. Okay, so this is referencing something somewhere at my user profile. Okay, outgoing signal reference. The same is true for other events. So each event you can put an outgoing signal stuff, a node, and an outgoing signal reference. You can in fact add more than one outgoing signal reference, and what is going to happen is that you're going to send the same signal to different places. Okay, so this is more or less what happens in general. This is activated when the event is triggered. Okay, so if this event evaluates to true, or this situation or some of the situation evaluated true, then the signal is going to be sent. Otherwise, it's not sent. Okay. Okay. So those are events. Then you have signals related to formulas. In fact, there are kind of two categories of signals. One related to events and the other related to formulas. When you have a node that has a formula, like in this case, you can have also an outgoing signals node, and that node can have an outgoing signal reference. And because this is related to a formula, by default, the formula value is going to be sent to at the signal message in case the consumer of the signal would like to use the formula value. Okay. Then any other node that has a formula, you can add an outgoing signals and an outgoing signal reference pointing to somewhere where we are going to send the signals to. Okay. So this is very much an overview of this. There is a deeper layer that we are going to see it in a bit, but this is like the overview of this. If you open the other nodes, you will find that there are signals almost everywhere here, because I am going to be my experiment here is that I'm going to recreate um, uh, the whole strategy that is running, sending the signals. I'm going to re-execute it here, but instead of reading indicators and taking action based on that, I am only going to take action based on the information that I received from this guy. So the test for in order for that to work, I need to send a signal for every single event and every single formula, no matter at which stage they are, including events related to orders. You will see that each of the events of each of the orders are mapped or are sent as signals, and each of the formulas are sent as signal one by one, all of them. This is not necessary in real life. You might send only one signal from one single order, from one single event or formula, or send them all. It's up to you how many signals you want to send. The system is flexible enough for you to do it as you please. So you can send signals only when you sell, when you buy, or when you some event that happen in your bot. It doesn't really matter. The system is the same. It works for all the possibilities. Okay. So this is an overview of sending signals with this trading system. Let's go to this trading system that is receiving the signals. You will see that it has an incoming signals node here, which activates the functionality somehow. You can think about that. Without this, nothing is going to work. So keep it in mind. And if you check the nodes, you will see that you have practically the same stuff, but instead of outgoing signal, you have an incoming signal, and this is a reference of an incoming signal that is coming through here. Okay, so how does this work? When the signal comes, does that mean that it's going to turn on this event? The answer is no. That doesn't mean that it's going to turn it on. In the same way, that doesn't mean that a formula event, when you have a formula event, or whatever you have one here, that doesn't mean that the value of the formula coming through the signal is going to be overwriting your formula event. It doesn't work that way because it wouldn't be flexible enough. The way that it really works is that at the code of your signal, of this event, you can do something like this. Check this out. You can say if signals, because signal is a special object that you will have available if you're using this functionality, is signal is an array, is not undefined, and the amount of signals in there is greater than zero, okay, then true, otherwise false. That means that just because the signal arrived, that it doesn't mean the event is going to be triggered. It's only going to be triggered if you put some condition like this. And the condition could be anything. You can say if the signal arrived and the candle close is greater than 30,000, then true, otherwise false. So the signal is just one more piece of data in the possibilities you have to combine that data with whatever other data you have available here so as to take the action that you wish. Okay, that is much more powerful than just receiving the signal and triggering the event. Okay, and remember that you can receive more than one signals at the same node, so then you can evaluate inside uh, each of these signals and probably check from when they are provided they're coming from, and make a decision if the signal from that bot is here, and also the signal from that other bot is here, then I will do something, otherwise I will not do anything. So it's really as powerful as it can be. Something similar happened with formulas. The formula value is inside the signal, but that doesn't mean that it's going to override your formula. So if you check, for example, this code, this is an example code. It doesn't mean that you have to put it, that is mandatory. What we are saying is this: last signal formula value equals 0. So I'm iterating over all the signals that I receive, okay, with a default value of 0. So in this case, because I am receiving only one signal, so this is going to work. So I get the signal, and from the signal I get source trading system node formula value. Okay, this is the way you get the value stored at the signal object information. Okay, so signal source trading system node formula value. Okay, so that's how you get the value. But I could make, for instance, this divided by 2, and then I would be using the formula value but divided by 2, or combining it, or doing whatever I want. Okay, so also this is powerful because it's not mandatory to use the formula value. You can use just the signal that arrive, or the value, or whatever you want. Okay, and that's how you do it. Okay, so this was a very quick overview. Everything else is the same stuff. Here you have event related signals and formula related signals with the level of detail of each node. So you can put them all, or you can put only one. Is exactly the same stuff. Okay, so finish with this overview. Now let's check this out. When I said that these signals are sent somewhere, the place they are sent is here. You have a user profile. You need to declare your user bots, okay, and inside there your social trading bot. You will need to have at least one social trading bot. I have two as an example, but all of this is working with only one. So at this social trading bot, I you need to have this. I'm not going to explain in this video what is a sign-in account and all that, or maybe I will, because probably people doesn't know. A sign-in account is part of the identity system that we use for social entities like social trading system, social trading bots, and social personas, and also for all the applications that a user can have. So it's the way that they identify uh, across the network, across the whole system. So in order to have this, you need your profile constructor to run a script that is called install sign-in accounts, and it's going to generate automatically all this. Okay, so without this, nothing is going to work. But if you run that, it's going to work. Okay, so Again, where the signals are going. Here at available system, you are declaring which are the signals available of this bot, social trading bot. So when some people will in the future be following your bot, okay, they will discover, because this is defined at your user profile, they will discover in this way which are the signals this bot is providing. Okay, so as you can see, the signals are organized in the same way that the trading system. You have trading system signals. Okay, and trading strategy signal. Remember, a trading system has a strategy inside. Okay, here is the signal that I was telling you that is required in order to enable the functionality. Well, that signal needs to point into this node. Trading system signal is the signal of the trading system. Okay, so thinking in that way. Without that, it doesn't. Nothing is going to work. But then you have the strategy and each of the stages. Okay, and each of the stages you might have signals for each of your orders. Okay, or for your events or whatever you have there. So, for example, the trigger on signal is this one. Okay, so from the both or from the trading system that you are emitting the signal of your trigger on event, then you point it into this node here. Okay, and the trigger off, you point in it here. The take position or whatever signal you do, you have to map it with the right node here. Why is that? Because the second user, the ones who is going to be following your signal, is going to come to your user profile, discover which signals you have, and is going to do the same thing for his incoming signals. So at his trigger on, he's going to point to this guy, okay? And this is what connects both trading system in the end, okay? This definition, this is a definition, okay? This is a definition of all the signals available provided by this social trading bot number one. Okay, so anybody can come and put a reference to here, and it's going to listen to the signals of this specific type that this bot is sending over the peer-to-peer network. That's how it works. Okay, so all the signals that you want to consume from this bot, you have to put a reference to the node that this bot provides here. Okay, and if you want to consume signals from other bots, you do exactly the same, opening some other user, some other bot, and you can consume multiple signals from multiple users, from multiple bots at the same time, and do whatever you like with that. Okay. Okay. Hope you understood this part. Okay. So the next the next piece of the puzzle are the the tasks here. Okay, the task has a few additions each. Okay, you need two additions. One, you need to add this node task server app reference. Okay, in order to define which is the task server app that this task is going to run, the identity which is going to run. And let me explain this. At your user profile, you will need to define which are the user apps that you are going to be using. Okay, why? Because every entity that connects to the network needs to sign their messages in order to certify that they are who they're supposed to be. That's how I can be sure that I'm receiving a signal from the bot that I am following and not from somebody else that changed it in the middle. Okay, by signing the messages, we are creating a cryptographic signature and also a hash that includes a hash of the message signs that, and if we are controlling that hash at the recipient, end, then we can certify 100% that nobody changed the message on the way. Okay, remember the message might be hopping through different nodes and going around on different places. Okay, so everybody has to sign the message, but we have two layers of identity here. We have the applications that connect to the network. Okay, they have their own identity. So for example, the desktop app or the mobile app or a task server, these are applications. So when they connect to the network, they have to prove their identity by signing their messages. So the network knows, controls that this identity is valid and belongs to some profile of the system that is already existing at the system, and it's not some random identity that doesn't exist. Okay, so it not only controls that, but it only uh, by signing with your identity, you are somehow declaring that behind you is this profile. Okay, so all of the identity must be declared. Okay, that includes the task servers, okay, that are going to connect to the network to put signals into the network or to retrieve signals from the network. Okay, the signals are not going to be retrieved only from the mobile app or the desktop app. The first implementation of all is by putting signals through a task server and retrieving the signal through the task server. That is an application that is managed by the platform, right? So these are the nodes that you have to reference from any task. Okay, so any task that you are running and that you were running until today, they don't need this because they don't interact with the peer-to-peer network. Okay, so they don't need an identity. Okay, so you can run a backtesting task or you can run a data mining task without this because they don't interact with the peer-to-peer network. But because this task is going to run this bot that is going to uh, interact with the peer-to-peer network, then that means that this task need an application identity. So you are referencing one here, and in this case, it's task server app 2. Okay, it could be 1 or whatever. In this case, it's number 2. Okay, the same is true for this task that is going to be receiving the signals, because it's going to receive the signal through the network, it's going to interact with the network. That means that it needs an identity as an application to interact with the network, and that means that you need to place a reference here to one of the declared um, identities of the network there. Okay, declare identity of application there. Okay, so then inside the task runs a trading bot. Okay, a trading bot instance. When when you're doing a back testing, you don't need to identify this trading bot instance, or you don't need to attach this to any social trading bot. Okay, these are two different concepts. The trading bot is the one who actually do all the calculations and do the trade, place the order, etc. The social trading bot, okay, conceptually is an entity that is the one that people can follow, and the bot can make posts and has a social life. Okay, this bot doesn't know how to trade at all, and it has no single line of code related to trading. Okay, but it's a social trading bot because through him a trading bot is trading. So in this case, this trading bot that is going to be using the logic of the trading system lightning strike outgoing signals, okay, is going to use this identity to send signals into the network. Okay, so it's going to use this bot identity, but the application is going to connect to the network as a task server 2 application. But the signals themselves are going to be signed by this bot. Okay, so when people follow this bot, they are going to check that the signature of this bot is on each of the signals. Okay, So that's how they are 100% sure that nobody changed the signal messages or information, um, and that is how it works. So you will need to reference a social trading bot, and the social trading bots, if I haven't shown it before, but I think I did, is what we have here. Okay, so we are going to be using this guy. Okay, so you need to put this guy in there. Okay, so this other link, probably this is not needed, but I haven't confirmed that yet. I don't remember, but most likely this is not needed because we are not going to identify ourselves as bot number one. I'm not going to delete it now because I know that it's working with this, but that is something that I have pending to do. Okay. Okay. So this is the basic setup. Then you will tell me, okay, but why this task? Well, in fact, yes. What you need to reference here is a social trading bot, not number one, but number two. Hold on. Social trading bot number two. Okay. So this is the story. Okay. Sorry. You need to reference here the bot that is following the other bot. Okay. So remember, this is a social network of bots. So this bot must be following this other bot. So this is going to work anyways without this bot following this bot, because still I am not checking at the peer-to-peer network who is following who for sending the signal. We are in version number 2, that will be ready in version number 3. Okay, so it doesn't matter if you put both 1 or 2, it's going to work anyway because all the signals are sent to anybody that is connected to the network today. Okay, but in version number 3, you better put here a bot that is following the other bot, and um, and that is that is going to be needed. But today we don't have an application to follow from one bot to another, so that's why I keep it open for now. Okay, so this is the explanation of this. The rest you already know it because it's exactly the same stuff. Okay, there are a few more other details that I'm going to go through now, and they are here at the user profile. At the user profile, you will notice that I have at my user profile this new section that is called user storage. Okay, this is relating to the open storage project, and the open storage project mission is to enable users to have storage container on the open internet. That means reachable by anybody because they have public IP addresses or whatever, and in order to facilitate the storage of information there that then can be retrieved from other users. Okay, so why do we need this? Because the peer-to-peer network is not handling the transport of the signals per se. Okay, the way that this works is the following. When your bot is sending a signal to the peer-to-peer network, in fact, it's not sending the information. What it does is the bot, what the system does is that the bot has this available storage, okay, and it has a storage container that is pointing to one of the storage containers that you have defined here. In this case, my trading signals, okay? So you can define one or more storage containers. So far, we have GitHub as a storage container provider, but later we are going to develop more providers, okay? Including a super algos provider, so we can have uh, our own system if you run it at the open internet to store information for you on the open, okay? But to come back to the explanation of how this works, when the bot produces the signal, it's going to uh, look at which are the available storage you have defined for this bot. You can have one or more, okay, more containers. If you have more containers, that means that it's going to be saved at many different places or more than one places at the open internet at the same time, okay? And that is good for resilience, because if the information is deleted from one of the places because the storage provider doesn't want you to have that kind of stuff there, then it's still going to be available some other place. Or if the GitHub is done, is down, maybe we can still retrieve the signal from some other place that is not GitHub. Not today, because today GitHub is the only storage, uh, the only container provider, but in the future we might have more than one. So in this particular case, I define this storage container, which is a repository that I created on GitHub, and take into account that this is not automated, the creation of this repository so far. So under your user account, you create a repository. You can call it like this or however you want, even in other user accounts too. Okay, so you create your storage containers, and then um, you link the available storage into your storage container that you want to record the information of the trading signal. And what is going to happen is that uh, when the system needs to send the signal, that it doesn't send it signal by signal, but it packages all together in a group of signals, that when it's trading live is one candle worth of signal. All the signal related to one candle are sent together. And when it is backtesting, it's all the signals of the backtest, if we are talking in a market uh, time scale, like 1 hour and above, or uh, all the signals of a single day, if we are backtesting in a time frame of 45 minutes and below, okay, it's going to package all the signals of one day and send it all together for efficiency, okay. So the signals are not going to, this package of information are not going to hit the peer-to-peer network, but we're going to do, the system does, is to save it in whatever place you define here, okay, and it's going to encrypt it before it save it, and it's going to send the file key or the information needed to locate these containers for that signal, and the password to decrypt it, okay, via the peer-to-peer network, to all the people or all the bots that are following your bot, okay. So the other bots, when they get this file key, they're going to look for these containers, download the data, decrypt the data, and then start processing the signals, okay. That's how this works. Okay, so let's go and check this out. I have to remember to show you, there is a detail, that there is a file you need to create so far that is not automated yet at this version. That is one of the two secrets file, where you're going to store essentially your GitHub or whatever storage provider token, okay, access token, so that the bots can access these containers and put there the signals files or retrieve from there the signal file. So in order to create that file, you need a code name that is unique. And to create a code name that is unique, I just put this GitHub storage container plus my username plus the name of repository, so that make sure that I'm not duplicating the code name of in any of my containers, okay. But I could have put only the number one here or whatever I want, just a random stuff. It would work the same. Then at that file, that secret file I will show you later, you will see that we have, or I can show you now before I forget, um, you will see that we have, where is it that I have this, okay. For example, here, my secrets is at the root, my secrets, okay. I will open this file, that has my API key for GitHub, my token, but then I'm going to delete it later. So here it goes. The file it should be here. This directory, it should be named like this, API secrets, and have this format, okay? Exactly like this, secrets, then no code name, the whatever I put as a code name, okay? GitHub storage container, my trading signals, and the API token that allows the bot that needs to get that information or put information in there, especially the one who has to put the information in there. The one who has to get the information, they don't need the keys because they read the information uh, not via the GitHub API, but via the public's interface of the web interface they have. So only to store the data, you need this file in this format, okay? So this is what you need, and you need it here. Okay. With that said, we have covered almost everything at a basic level. Okay, so we are going to run this to see how it works, and then we are going to go in a second round with a little bit more of detail. Okay, so to run this test, I'm going to do the following that I usually do. Let me go to the platform. I'm going to, this is not needed, but just for me and you to know that this is really producing the data. I'm going to my data storage and delete algorithmic trading folder. So all the backtests and stuff that I have run before are gone. And that means that now I'm going to come here. And for running this, you need to run also the peer-to-peer network itself, okay? So I will need to teach you a little bit about the peer-to-peer network, it seems. Okay, I will do that later. First, I want to show you how it works. I have the peer-to-peer network running in this Visual Studio Code. I know that it's running because all this is good, okay? So I will follow up that explanation after we see how this works, okay? So how to test this? It's very simple. You just run all the tasks, and the task that is sending the signals is going to run, and the one that is receiving the signals is going to run too. Okay, it takes a while, but it does. My machine is like not so fast lately. Okay, so it's running. Okay, it's running. So then the next thing to do is we're going to use this session to listen to the signals. So this is going to start running, but it's going to get stuck. This is the lightning strike strategy that everybody knows, running on September 1, 2020. Okay, and then I'm going to run the session for sending the signals. So here we go. You will see here that is going through all the candles of the day. Okay, and there's almost no delay for the normal speed because the signals are sent in this moment. So here is going to GitHub, saving this file or encrypting, saving, and then sending the key over the peer-to-peer network. Okay, and it's done. So this guy received the signals over the peer-to-peer network. The file key went to GitHub, got the file, decrypted, and start processing all the signals. Okay, and there it finished. If we had more than one day, this would continue processing the second day, then the third day, then the fourth day, and each time would be doing the same process. Okay, we don't need to test that now. And at each day, it would send a signal and it would start processing this. So it will be like one day behind all the time. So we can stop this now. We can stop it, and if we check the charts, we have that the bot sending the signal has the chart that we already know for this back test, okay? And the guy who was receiving the signals has exactly the same chart, okay? It's one day with some activity at the beginning and some activity in red at the end. So exactly the same because it did exactly the same, but without reading the three indicators that the other guy was reading, that was candles and resistance and support, and probably I don't know what else. But the other guy, this guy is only reading the candles in order to produce its own simulation, and all the other stuff is produced with information that came through signals. That means that the, 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 the value of the formulas for where to put all these orders and when to activate each of these orders, and absolutely everything came inside each of the individual signals that were packaged and sent via the peer-to-peer network. Okay, so this proves that we can send and replicate a strategy in detail with a very high granularity, okay, across the internet over a peer-to-peer network. Okay, it's working. So the next thing I want to show you is this detail of how the information is stored so that you have a better idea of this. So if you check my user or your user once you have it running in GitHub, I have this repository, my trading signals. Okay, so this is a little bit messy here because I have some tests, but the structure of this is here, 2020, 22, January. Today is 24, okay? And these are all my tests of today. Now it's 17 hours, 5 minutes, okay? And these are the two files, one from 1st of September, the other 2nd of September, that is almost empty because it detects that it has to stop there, okay? So the 1st of September is a file that I will open the file, okay? Okay, so this is not the first file, this is the second, but it's in the wrong order. Okay, so this is 1 day worth of signals at 1 minute with lightning strike, sending signals of absolutely everything is 6 megabyte. So this is what we are avoiding sending through the network. It's just being sent, recorded here, and we send this location and the way to encrypt this data. If you want to see the data, well, good luck with that because it's encrypted, okay? You cannot see it, as well as nobody can see it, or just like that, okay? Beautifully encrypted. Not even GitHub can know what you have here, okay? So these are all the signals that produce that backtest, essentially. So if you add to this encryption, you add the fact that the name of the repository, you might put some random string of number and letters, then you have GitHub wondering what is actually going on there because it doesn't know that comes from superalgos, because it doesn't even need to be at your profile. You can have a second profile for storing information that is not your actual profile, okay? And the name of the repository, you put just one random string of number, and then these kind of things are going to be recorded there. Nobody can know where they are coming from or what is going on there, and nobody can even suspect that these are signals from the Superalgos trading system. So even though the password is going through the network through to all the bots that are following your bot, but from the point of view of the storage provider, that can be GitHub, Amazon, or whoever, They don't really have any clue, so they have no arguments of why they should delete your stuff. So probably they won't do it. Okay, so that was something I wanted to clarify. Okay, so this is how this works. This is the very basic explanation. There is a deeper explanation that doesn't go that much deep, but I want to cover it at this same video. That is this. When you're sending the signals, if they are signals related to events or formulas, you have the opportunity to add. You have the opportunity to add a context, okay, to the signal, okay. So if you add this add signal context formula, then you have the possibility to write a formula that is going to return a context object that is going to travel inside the signal and is going to be available at the bots that consume the signal. What can be the information that you put in the context? Well, pretty much whatever you want. Okay. From a formula here, you have access to any of the uh, session parameters, to the user defined parameters. You have information of all the indicators that your strategy depends on, and you have also your trading engine. You can fetch information from any place of your trading engine, okay, with information, up-to-date information of anything that is going on at execution time at any candle that you're processing. So you might fetch any of this information and put it as a context for that specific signal, okay. And whatever you put in there is going to go with the signal. I have an example here that is not being used, but oh no, it's not here, it's here. Okay, so I create the context object that is, for example, profit loss, and I go to the trading engine and fetch from there, from the episode statistic, I fetch the profit loss value at this specific moment in time, also the hit fail value and the return of investment value. So that means that, for instance, the guy receiving receiving this signal might say the following: if the bot providing the signal has a return of investment greater than 10%, then I use its signal. Otherwise, I don't use its signal, or I multiply whatever value of the formula by whatever else. Okay, so this is a very powerful mechanism to send information to all your follower bots exactly at once, or at each signal that you want, and whatever information that you want. Okay, so the doors are wide open for you to do as you like. You have this tool at your disposal. Okay. um, I don't know if I have put an example here. Probably yes, I don't remember, of how to consume that context information. I think the example should be at the same place, initial targets here. So probably here we are going to receive the context information. No, I didn't put an example, but my guess is that if you use context dot whatever properties you define on the other side, then you will have access to whatever values are coming inside there. Okay, so this is very powerful stuff. Okay, so this is the deeper information I was talking about. um, the last thing probably for you to test this is some quick explanation about the network, the peer-to-peer network itself. Let me go here. You will need to run one peer-to-peer network node, and to run a node you need to define it here. Okay, You need to define it here. Uh, when you define it here, mm, I will leave this workspace now because I need another workspace that you can also access because it's also available there. That is called Peer-to-Peer Network Demo. You don't really need to go here. You can add a few plugins that are the networks. Okay. So, but to explain this better, I will switch to that workspace. Hold on. So this would be the last step, essentially, of all. And essentially, what you will see when this loads is that what we have is the possibility to have already implemented in the version 2 of the peer-to-peer network to have two different categories of network, like open networks and closed networks. Okay, closed or permission networks. So open networks, today we define only two that are mainnet and testnet. Okay, these two. And permission networks, anybody can define, create their own permission network of nodes. Okay, so how does this work? You come here and you define at the peer-to-peer network nodes, you create a network node. This is the definition. It doesn't mean that it's going to run anything. This is just a definition. You create this node here, and then you will need to define at this node, you will need to define which is the network that you want this node to be part of. Okay, so each node can have a peer-to-peer network reference. Okay, only one. So if you want to have one node at mainnet and one node at testnet and one node at the private network, then you can create three nodes, and one link testnet from here and the other reference mainnet and the other whatever other private network. Okay, so that's how it works. Then another thing that you need to define is which are the network services that you want the node to run. Okay, so the node, if you don't add this small structure here, it's not going to run anything at all. It's just going to run without any network service, and you need it to run the social graph and trading signal. There are network services running at each of the nodes. You might run a node only with one of these guys, and that's perfectly okay. Okay, so it depends how you want to run those nodes, is how you configure this stuff. Okay, the next thing you need to know is that you can create permissions peer-to-peer network by adding one here. Okay, permission peer-to-peer network. You put a name to it, for example, whatever, bata, and then you create groups and start creating this permissions granted node where you reference some other users or yourself, and this means that these are the users that are going to be able to access a peer-to-peer network node that is part of this permission network. Okay, so if this node, peer-to-peer network node 2, instead of being testnet, I put it to be part of this other network. Okay, reference detach, bata. Okay, then this means that this node is going to be a private network, part of a private network. It can be a network of only one node or can be 1,000 nodes, it doesn't matter. Okay, all the nodes that are part of the same network are going to connect between them automatically, so you don't need to worry about that. Mainnet nodes will connect with mainnet node, testnet node with testnet node, and whatever private network are going to connect between each other automatically. Okay, just because you set this up in this way. Okay, but in all cases you have to declare which service you want to run. Okay, so for example, if a signal is put into mainnet, that means that everybody connected to mainnet following the bot that emitted the signal is going to get that signal. If a signal is if a signal is put into testnet, all the bots that are connected to testnet are going to get the signal. And if the signal is put on a permission closed network, then that means that only the ones who can connect to this network and are following the bot that put the signals are going to be able to get the signal. Okay, that's how this works. So we can have public networks that today I define it only these two until somebody comes with some other network that makes sense. But anybody, and I mean any user, can have one or many permission networks by themselves, which could be, for example, trading groups that wants to share signal between themselves, or somebody running a business of trading signals that have subscribers. Then you grant them permission here, and they will automatically be able to connect to your network and then consume your signals or whoever puts signals there. Okay, so all of that is enabled by these features that I just described. And if you want to test the trading signal features, then you need to define your node. Okay, so nodes are also have an identity and also have a sign-in account. Okay, that's how application that connects to nodes, they can certify that they are connecting to my node here, peer-to-peer network node 1, that is mine, belong to my profile, and not to some other service running for by some other people impersonating my node. Okay, so this is reciprocal. Not only the node knows which application is connected to itself, but also each application knows exactly which node they are connected to, because the node also have to sign their own messages so that the client's applications that connect to them, they can certify that they are really connected to my node and not to some other's node. Okay, perfect. So this is all you need to do now, and remember that for creating this sign-in account, you first have to create your node, your user application, your trading bot, and whatever you need. And then when you finish, you come here and create and run the install sign-in accounts. And this is going to recreate all these icons that are going to have a signature inside, and also they are going to you're by doing this you're creating a file automatically. Here are the secrets. This is the other file that you've seen here. Okay, with this file in my secrets is the identities of all your applications and nodes and social trading bots. Okay, these are the identities with the private keys, okay, of each one. So in this version we have an unencrypted file in your own computer. Okay, we are early, but this is where all the identities are. And with this private key is that each of these applications or bots or network nodes are signing their message. Remember, you need a private key to sign a message. Okay, so that's how this is working. Okay, so if I come here and I run install signing accounts, I am regenerating all the private keys by a new set of private keys, and everything continues working perfectly well. Okay, the only private key that is not there is the one from my user profile, because this you are supposed to have it in a backup, because this is the one holding your token. The idea of having signing accounts everywhere is just exactly for that, so that your private key of your profile is never at even at your own computer. It should be at cold storage or somewhere else. Okay, but not at a computer or a server where you are running a node. Um, okay, so this private key can be regenerated many times. There is no problem with that, because they are part of your profile. Okay, so this is what you need to know regarding network nodes. So I save this. Remember that you uh, okay, you generate your tokens on GitHub and blah blah blah. Okay, so this is all for now. This is what you need to know to actually test the trading signals. You can reproduce the same test by creating. You will have to probably do it with. I don't know if you can run it with the signals pointing to my own profile. Probably yes. Um, or maybe not, because you cannot impersonate me in producing the signals. Uh, so you will have to, at your profile, create all the structures that I describe, and then you can at a trading system, you can reference these signal definitions, and by that way sending the signals through there and creating this another strategy referencing the incoming signals from the same definitions, and you will be setting up the same thing that I did, even for one signal or two, whatever you want to test, or you can start using if you want. This is ready for usage. Okay, so this is all for now. With this, I finish the trading signals project version 2. Okay, there will be another version once there is a new version of the peer-to-peer network and social trading project 2. Okay, this all goes together. Okay, so I think that I cover everything. I hope you like it. Thank you for watching, and see you next time.